Okay, so let's start with just some evaluating expression stuff. So they tell you that you have this expression right here, 7x plus 8x, and then they tell you what x and y are. All you have to do is plug those in where x and y are. So this is going to be 7 times 3 plus 8 times 2. So that's going to be 21 plus 16, and that's going to equal 37. Okay, so now let's go to some practice with fractions. So on the SAT for now, you do have a section without the calculator. ACT, you have your calculator, but sometimes they might give you the answer choices in fraction format. Now you can always convert each of the answer choices into a decimal to like figure it out, but it's a lot easier if you just like remember how to do like your operations with fractions. So this says find the product of 2/3 and 9/4. So product means that we're multiplying these together. So we have to do 2/3 times 9/4. Now, another thing you want to check for is anything that you can cross cancel to save yourself time simplifying later. You can just multiply across and simplify at the end, but that's going to be a lot more tedious. So I know 2 goes into 2 one time, it goes into 4 2 times, so I can cancel those. I know 3 goes into 3 one time, it goes into 9 3 times. So then now I can just multiply across 1 times 3 is 3, and 1 times 2 is 2. It says to put your answer as a mixed number. So when we want to turn a improper fraction into a mixed number, it's the top number goes on the inside, and we're dividing by the bottom number on the outside. 2 goes into 3 one time. 1 times 2 is 2. Subtract, you get 1 as your remainder. Now the remainder is what's the numerator part of your mixed number, and 2 is the denominator, like whatever you're dividing by goes on the outside. So it would be 1 1/2 for this one. Okay, so now let's go to the ratio and proportions problem. So it says a recipe uses 4 cups of flour for 4 cups of sugar, for 6 cups of sugar. How much flour, so we're looking for flour, is needed for 9 cups of sugar? So let's set up a proportion. The easiest way to go about this is when it's a direct proportion is to just make sure the units match on top and bottom for each relationship on each side. So like each side is a relationship. Like 4 cups of flour, so 4 flour is related to 6 cups of sugar. So I put F for flour, S for sugar. And then just make sure the top units match and the bottom units match when you put the other relationship on the other side. So the other relationship is this mystery number of X cups of flour is being related to the 9 cups of sugar. So then all you have to do, now that you have your proportion set up, is cross multiply and solve for x. So 9 times 4 is going to be 36. 6 times x is 6x. Divide by 6 on each side to get that x is equal to 6. So now let's go to this problem right here. So it says write an equation for the total cost, which is represented by C, of buying N notebooks at $2 each. So on the exam and for like a lot of these problems, the each part, like whatever number's near the each, is usually what you're multiplying by, whatever like the variable is in your problem that you're multiplying by. So it's $2 for each of the N notebooks, so it'd be 2N equals the total cost, because it's $2 for each of the N notebooks you buy. So like, let's say you buy 5 notebooks, you could put in 5 for N, 2 times 5, that would give you the total cost $10 for those notebooks. Okay, so now let's go to this next part. It says determine the surface area of a rectangular prism with the dimensions 2 centimeters, 3 centimeters, and 4 centimeters. So rectangular prism, that's the shoebox one. And someone asked about going back to the previous question. Yeah, I will in a second. So surface area of a rectangular prism. So rectangular prism is the one that looks like a shoebox. So like, I'm terrible with drawing, but this guy right here is the rectangular prism. So surface area just means you're adding up the area of each of the faces. So like this side, and this side, and this side, and this side, and the top and the bottom. So you can find each of those individually and add all them up. Or you can memorize that like the surface area for a rectangular prism is going to be equal to 2 times, and then it would be like each of the different numbers times each other and all added up. So like what I mean by that is like 2 times 3 plus 2 times 4 plus, and then the only one left that you haven't multiplied together are 3 and 4. 3 times 4. So you can remember that formula, or like I said, just add up the area of each side. So then it would be 2 times 6 plus 8 plus 12. And then 6 plus 8 is 14. 14 plus 12 is going to be 26. 2 times 26 is going to be 52. And then it would be centimeters squared as the unit, because anything with area, we put squared as the unit. And someone wanted this question. I'm assuming you meant this question since I had like scrolled past it. If you want to like just look at that really quick or ask a question about that, do it in the comment now. If not, we'll keep going. Okay, so also I'm going to post this on YouTube later, just so you guys know. So let's go to the statistics and probability problem. So it says that the heights of 4 students are all of this. Calculate the median height. So median, think of it like the median is like how it is with the road is how I remember it. Like the median is the middle, the divider between the two roads, like the middle part. So it's the middle number when you order these from least to greatest. So if I order these from least to greatest, it would be 145 goes first, 150 goes next, 155, and then 160. Now I'm looking for the middle number. Well, the middle number, there's actually 2 middle numbers here. When that happens, you can't just like pick one of them. You actually have to find the average of the 2 middle numbers. So I need to then do 150 plus 155 divided by 2 to find the average of those. So then that would be 152.5 centimeters for the median. So now let's go to the next one. It says that we're solving for z. So I want to get my z's on one side and like my numbers on the other. So I'm going to start by subtracting 10z from each side, because that's going to eliminate it over here and move it over to the other side. So 5z minus 10z is negative 5z, and that equals 15. Now if I divide by negative 5 on each side, I'm going to get that z is equal to negative 3. And then let's go to this one down here. So this is just like a review of integer operations. So just remember, when you have minus a minus with integers, it's going to turn into a plus. You can kind of remember it too, because like it looks like a plus, like the minus parentheses and the minus. So it turns into a plus. So this becomes negative 3 plus 9. So if I have 3 negatives and I add 9 positives, then I'm going to have 6 positives left. So now let's go to the exponent and powers one. So a lot of people mix this up. When it has like a negative outside, this is completely different than saying this. These are 2 completely different things. The one over here says we're taking the negative of whatever positive 2 to the 4th is. So this is saying we're taking the negative of 2 to the 4th, which is 16. So that would be negative 16. This one says we're taking negative 2 times negative 2 times negative 2 times negative 2. So this one would actually be positive 16. Those are 2 different things, so just be aware of that. And then we have over here, calculate the cube root of 27. So cube root of 27 would just be 3, because 3 to the 3rd power equals 27. Are those actually questions in the SAT? No, this is a pre-algebra review right now, because this is like a lot of the stuff on the SAT relies on you knowing this basic stuff. So that's what we're doing right now to help you guys prepare for the ACT and SAT. We're not doing exact SAT, ACT questions. We're getting to like the foundation to make sure you guys all know this. So let's go to the inequalities stuff. So like this might be something that you see on like, this would be an example of something you might see on the SAT. Like they like to do graphing questions a lot where you have to match a graph and equation or a graph and inequality. So this says we have to solve and graph. So let's first start with the solving part. So solving, basically, just like with the equation, you try to get x by itself. So I'm going to subtract 3 from each side so that x gets by itself. So when I subtract 3 from each side, it cancels out on the left-hand side, and then we get x is greater than 2 on the right-hand side. So now I've solved it. Now I'm going to graph it. So when I'm graphing it, I have to think, okay, x has to be a number that is greater than 2. If I were to like think of it, I like to say think of it like there's an equal sign there until you have to do the shading and the like dotted or solid line part. So like pretend that this was x is equal to 2. How would you graph that normally? Well, you would go and find on the x-axis where 2 is, right here, and you would draw a line through there. You do the same exact thing, except you have to shade in as part of the inequality, and you have to decide, am I doing a solid or a dotted line? So there's still a line that goes through x where x is 2. You just have to decide, is it a solid straight line or is it a dotted line? And it's going to be a dotted line because whenever we have these guys, like with, oops, I meant to put like greater than and less than. Whenever we have these guys without the little line on the bottom, that's dotted. When they have the little line on the bottom, that's when you have a solid line. So this is going to be a dotted line through where x equals 2. And then now I have to decide, okay, where am I going to shade it? So I'm going to shade it. It says x has to be greater than 2. So x can be all over here because all of these represent x values that are greater than 2. So that would be that one. And then let's go to this next one. So it says if 5 kilograms of apples cost $20, how much would 8 kilograms cost? Again, put a relationship on each side and match the units on top and bottom. So the first relationship is 5 kilograms is related to the $20. So make sure you have dollars on bottom and kilograms on top to match for your next relationship. So the next relationship they're asking about is that it would be 8 kilograms and we want to know how much it costs. So x is going to be down there with the dollars. So now we're going to cross multiply and solve for x. So 5 times x is 5x. 8 times 20 is 160. So then we're going to divide by 5 on each side, and that's 32, right? Yeah, 32. So x would be $32. And then let's go to percents. So if a shirt is marked down 15% from $40, what is the sales price? So there's 2 ways to do this problem. So I'm going to show you the 2 different ways. So the faster way is to say, okay, it's marked down 15% from $40. So $40 is the original price. If I'm marking it down by 15%, I still am paying 85% of the original price because 40 is the whole price, 100% of the price. If I take away 15% of the price, I now have 85% of the price. So I can just find out what 85% of $40 is. So I can say, oh, I'm going to do 0.85 because remember you have to turn it to a decimal by moving the decimal point 2 to the left. And do 0.85 times 40. So now 0.85 times 40, that's going to be, well, I'll show you guys off to the side how to do it, like with, what do you call it? Like the column way, so we can review like the multiplication steps. So it would just be like 0 times 5, 0 times 8, both of those are zeros. When you're done multiplying with something, you have to make sure that you don't have to, but I like to do it just so I don't forget, cross out what you just multiplied by and add a 0 to the next column. And then it's going to be 4 times 5, which is 20, keep the 0, carry the 2. 4 times 8 is 32, plus 2 is 34. So basically you just pretend, like with decimals, you pretend that it's regular 85 times 40 until the very end, and I'll show you what you do at the very end. So now we have this, and we're at the very end of our problem. When you're at the end of multiplying with decimals, what you do is you count in the total problem how many digits are after a decimal. Well, there's 1, 2 digits after a decimal because you have the 8 after the decimal and the 5 after the decimal. So in your answer, you also have to have 1, 2 digits after a decimal. So that's where you decide, that's how you decide where the decimal goes. It has to go after the 4 so that there's 2 digits after the decimal. So the answer would be 34. Now that's the first way to do it. The other way that you could do it is you could say, okay, I'm going to find out what 15% of 40 is, and then I'm going to subtract that from 40. So you can do that as well. You can say, okay, I'm going to do $40, and then I'm going to subtract whatever the discount is, like what is being marked down, which is going to be 15% of 40. So either way, both work. So then let's go to the next one. So we have a function g g of y right here, and it says evaluate g of 3. So what's in our parentheses right now, let me actually like zoom this in a little bit more. What's in our parentheses right now is 3. So 3 is taking the place of y everywhere in our problem. So to find g of 3, I have to replace every y with 3. So it has to be 3 squared minus 4. So that would be 9 minus 4, which equals 5. So then let's go to this next one. It says find the distance between these points. So this is a review of distance formula. So distance formula basically says, let me just rewrite it over here. This is the distance formula when you have 2 points, and you can label either of these, like x1, y1 could be this one, x2, y2 could be this one, as long as you're consistent with like the 2's go together and the 1's go together for your point. So like I'm going to just label this as x1, y1 right here, and then I'm going to label this one as x2, y2, but again, you could have flip-flopped it as long as the 1's go together and the 2's go together for the same point. So now I'm going to just plug it into the distance formula. So x2 is 5, x1 is 2, so I have 5 minus 2 squared, plus y2 is going to be 6 minus y1, which is 3 squared, and all that's under the square root. So that has to equal to 5 minus 2 is 3, so then 3 squared is going to be 9. 6 minus 3 is 3, and then 3 squared is 9 as well. So then now we have the square root of 18. So now let's see if we can simplify that. Well, 18 is the same thing as 9 times 2. So 9 I know is a perfect square because 3 squared equals 9. So I could take out a 3 and then I leave the root 2 on the inside to simplify it. So that would be, whoops, the final answer. Sorry, I cut it off a little bit. But that's all I do. I just break it up into factors to simplify and take out any perfect squares. Okay, so let's go to the next problem. So this is just, a line plot. They've been liking line plots and box plots for some reason on the past couple SAT exams. They didn't used to like do it a lot, but that's why I put this on here. So a line plot is basically like, you have to think about it as like a number line kind of, where like the data points, like what numbers you're talking about with the data, go on the number line. So like I'm talking about the number 3, 4, 5, 6, 7. So those are the numbers I'm going to put on my like number line part. And then what I have to do is I'm going to put a dot on like for each time that that number occurs. So like 3 in the list occurs 1 time, so it's going to get 1 dot. 4 occurs 2 times in the list, so it's going to get 2 dots. 5 occurs 1 time in the list, so it gets 1 dot. 6 occurs 3 times in the list, so it gets 3 dots. And then 7 occurs 1 time in the list, so it'll get 1 dot. They'll usually give it to you like this, like they'll give you the line plot first, and then you have to go and turn it into, like, you have to basically know that this means this to find things like mean, median, mode, and range is usually how they would ask this type of question on the SAT. Where do I find the SAT? If you mean to sign up, like signing up for the SAT, that's just the College Board website. If you're talking about this document, this isn't an SAT review. This is just like a prerequisite, like this is a pre-algebra review. This is the free version in my TPT store. If you go to my website, well, it's in my profile, agtutoring.com. You'll see like where it says free and paid materials. There's a link there. And this is under like pre-algebra. There's a free version and then there's like a $3 version, which has like 100-something questions. Just because like a lot of people miss like the number one thing I would say people miss on the SAT is like basic pre-algebra stuff. Like they get all the hard part right of like setting up the problem, and then they forget like their basic stuff, like adding integers, how to do fraction operations, like what a dot plot is, like things, distance formula, things like that. So that's what this review is for. So then let's go to sequences. So this is something that you won't see on the SAT, but you'll see it on the ACT. So it says write 2 equations for a sequence where each term is double the previous term. with starting with 3. Write an equation using the explicit formula, and then write another equation using the recursive formula. So this is saying that we're doubling. So whenever you're like multiplying by something, that's going to be a geometric sequence. So that's important because when you memorize the formulas, you need to know if you're using like the geometric one or the arithmetic one. So let's start with the explicit formula. So the explicit geometric formula is like this. It says that whatever term we're finding, like n would be like, if you want to find the 10th term, you would write like a with a little 10 right there for n. And that would mean like a of 10 is the 10th term. So this is saying like a for any n, like any like term in the list, is equal to whatever the first term is on the list. That's what this means. Plus, and then it has to be what's it called? It's R is the common ratio is what we call it. So R common ratio is basically like what you're multiplying by each time. And then it's being raised to the n minus 1 power. So it says we're doubling. So that means that like R has to be 2. And then they told us that our first term is 3. So A1 has to be 3. So if we were writing an explicit formula, it would look, oh wait, sorry, I meant to put like, this is times. I don't know why I wrote a plus there. That was dumb. This is supposed to be times. And then this is supposed to be times 2 is our common ratio that we're multiplying by, and then to the n minus 1 power. So that's how you would set up the explicit formula. Now the recursive formula is different. The recursive formula is kind of like it has 2 equations kind of with it. So you basically have to write what the first term is, a of 1, which we know is already 3, like we already figured that out from the problem. And then after that, what you have to do is it's a of n is equal to whatever the common ratio r is times a to the n minus 1. And we know r, like what we're multiplying by, is 2. So this would really be, we're going to erase that r, and that's going to be 2 times a of n minus 1. And a of n minus 1 just means like the term before it, like the previous term for whatever term you're trying to find. Like if you're trying to find the third number in the list, you would put a of 3 is equal to that, like because the n would be 3 if it's the third number in the list. And then you would just have to do 2 times whatever the second number in the list is. That's all that means. Okay, so let's now go to number 18. So this is just absolute value, just to like remind you what it is. So you would do 5 minus 9, that's gonna be negative 4. Absolute value just means you turn it positive, like whatever's on the inside positive, so this would just be positive 4. Let me get water really quick, guys. Okay, thank you guys for liking and sharing the live. Remember, I have a bunch of free resources on my website. It's linked in my profile. But I have a bunch of free, like if you go to my homepage, right there it says free and paid materials. I have a bunch of free ones I've uploaded and paid ones. This happens to be a free one that you can get later if you want to try it on your own. So then this says, write this in scientific notation. So basically scientific notation is the thing where it's like times 10 to some power. And you can always check scientific notation because like you won't see this on the SAT, but you'll see this on the ACT. Like you can check by just plugging it into your calculator a lot of the time, or just like doing the mental math. And it kind of makes sense because if you're saying, okay, what number times 10 to what power has to get me back to this, you have to think, okay, first, the number that goes here, the rule with scientific notation is that it has to be like a number that's between 1 and 10. It can't include 10. Like basically it has to be like a single, not a single digit, but like, how do I say this? Like you can't have like 42. You have to have 4.2. Like it has to, the number right here has to be a digit between 1 and 9 is basically what the rule is. So I have to put a decimal there to be 4.2. So I know that that's how I have to start my scientific notation. 4.2 times 10 to some power gets me back to this really small decimal. So think logistically, like, are you going to be multiplying by 10 to like a really high power or a really low power? Well, it's going to be a really low power because you're trying to get to a lower number. So that's kind of how you can remember if the exponent's going to be negative or positive. So in this case, we're going to have a negative exponent. And then the number that goes there is just how many times the decimal had to move. So to get from here to behind the 4, it went 1, 2, 3, 4 times. Like it went 4 bunny hops. So it has to be -4 up there. So then let's go to this next one. And all we're doing is, this is just reviewing, like combining like terms. So 4y and 7y are like terms. So 4y plus 7y is 11y. And then we have -2 and +5. -2 plus 5 is just gonna be +3. I like to remember, like a lot of students will forget the negative right there because they think they just have to combine 2 and 5 and they'll get 7. I like to remember, just always keep the sign that's to the left when you're combining like terms, is an easy like kind of rule. So that's why it's going to be 3. Now we're going to do some factoring. So with factoring first, I'm going to say, okay, can I take out a GCF, a greatest common factor? So there's actually 2 things that I can take out here. 3 goes into both of these, so I can take out a 3, and also y goes into both of these, so I can actually take out a 3y. If I take out a 3y from 3y squared, what am I left with? Well, I'm left with y, and you can check it because 3y times y gets you back to 3y squared. Now I'm going to do the same thing, but with -12y. So if I divide out 3y from -12y, what am I left with right here? Well, that would be -4. And again, you can check it because 3y times -4 is going to be -12y. So that would be your final answer. What age is this test for? This is pre-algebra, so this is like middle school math. But a lot of the SAT and ACT test you on like, these are prerequisite skills that you need, and sometimes they'll test you straight up on like pre-algebra stuff. So that's why we're going over it, because a lot of people forget that since they learned it in middle school. So let's go to the next one. It says we're going to graph this equation right here. So remember with graphing a line, which we know that this is a line or a linear equation because it's just a regular y and x, like there's no squared or cubed or anything like that. So I know that it has to follow the format of y equals mx plus b. So b right here, that represents the y-intercept, and m is our slope. Those are the 2 numbers that are most important for the equation when you're trying to graph. So 3 is basically my y-intercept. So I have to go to the y-axis, and where it intercepts the y-axis, touches the y-axis, is at y equaling 3. So that's where I'm going to put a dot, at y is equal to 3. Now, m, you'll see, is always multiplied by what the x is. So what number is being multiplied by x? It's 2. So that means that our slope has to equal 2. So our y-intercept is 3 and our slope is 2. Now slope tells me the change in y over the change in x has to be equal to 2. You might also know this as rise over run. So I'm going to put that also for people. Now 2 is the same thing as 2 over 1, and that makes it a little easier to visualize what we're going to be doing with our slope. So the slope here tells me y is changing by +2 and my x is changing by +1. So that means I have to go up 2 and right 1. So up 2 and right 1. Up 2 and right 1. And then that's how you can see like how the graph goes. So that would be an example of one of those. And let's now go to transformations. Okay, so you're going to translate this point 2, 5. It says 3 units up, and then we want the coordinates of the resulting point. So remember, a point is always x, y. If you're on the xy coordinate plane and you're at 2, 5, like let's just draw it out. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So 2, 5, let's say, is right here. If I want to go up by 3, that means that my x is going to be the same, but my y is going up by 3. So I need to do 3 more for my y to get my new coordinates for the translated point. So I'm going to keep my x the same. My x is going to be 2, but my y is going to go up by 3. So 5 plus 3 is going to give me 8. So this would be the answer. Okay, so then let's go to this next one. What is the probability of rolling a 4 on a standard die? So like dice, like what you roll in like Monopoly and stuff, like on a board game. So those have 6 sides on them. So each side is like, you can either roll a 1, a 2, a 3, a 4, a 5, or a 6. So there are 6 total outcomes that we have. So the total number of outcomes is on the bottom. Now the desired outcome, or the outcome we're being asked about in the question, goes on top. So the desired number of outcomes is going to be that you roll a 4, and there's one of those possible outcomes. Because there's only like one way you can roll a 4. Like you're gonna land on the 4 side. So this would just be 1/6. Okay. So now we're going to be doing the simple interest thing, which is calculate the simple interest on $200 at 5% for 2 years. So that would be the principal, like the principal is like what you start out with, like $200 times 0.05, and then times 2, and then, whoopsies. And then that's going to be $20. Oopsies. Okay, there we go. And then let's go to this next one where we have evaluate this, its order of operations. So this is just PEMDAS. So P stands for parentheses, E stands for exponents, M stands for multiply, D stands for divide, A stands for addition, S stands for subtraction. So we're doing those in this order. Like that's the acronym that teaches you the order you're supposed to do things in. So let's start with P. We have something in parentheses, so that's what we're going to do first. 5 minus 3 is just 2. So we did parentheses, and now I'm going to copy down the rest of the problem. So then exponents, there's no exponents, so we can skip that. Then we have to do any multiplication. There is multiplication. 2 times 2 is 4. And then I copy down the rest. There is no division, so we can skip that. There's addition. 6 plus 4 gives us 10. So that would be our final answer. Okay, so let's go to this next one. We're going to do, this is just like ordering fractions and like testing you on some vocabulary, because like people will get stuff wrong because they forget something simple like what descending means. So like if it's in descending order, it's basically like another way of saying decreasing order, like you're going from greatest to least. And the trick that I teach students with fractions is this always works, where if you multiply the bottom of one, like the denominator of one times the top of the other, so like 4 times 1 is 4, and I do the same thing here, 2 times 3 is 6. If you compare those numbers, you can compare the fractions accurately. So like 4 is less than 6, so that means that 1/2 has to be less than 3/4. So now we can do 3/4, and let's compare it to 2/5. Do the same thing. 3 times 5 is 15. 4 times 2 is 8. 15 has to be greater than 8, so that means that 3/4 has to be greater than 2/5. So we have 3/4 is greater for each of them, so that's the greatest one. And remember, we're going in descending order, so it's greatest to least. And then after 3/4, we're going to have, now we have to decide if 1/2 is less than or greater than, 2/5. So then 1 times 5 is 5, 2 times 2 is 4, 5 is greater than 4, so that means that 1/2 has to be greater than 2/5. So then it would be 1/2, and then it would be 2/5. So let's go to the next one. So we have to determine if this is rational or irrational. So with square roots like this, these are always going to be irrational. So you can kind of just like remember that. like rational also, like rational has the word ratio in it. So if you can easily make a ratio or a fraction out of it, then it's rational is another shortcut that you can use. If you can't, then it's irrational. Like there's no easy way to make a fraction out of this. So it's irrational. So then let's go to the next one over here. So it says, if a car travels 180 miles in 3 hours, what is the speed in miles per hour? So miles per hour. So we're going to do 180 miles divided by the number of hours, and that'll give us miles per hour. So 180 divided by 3 is going to be 60, so it's 60 miles per hour. So now let's go to this one. We have to simplify the expression right here, but then we have to make sure that our answer only contains positive exponents. So you're probably used to seeing this. Remember, a division sign is the same thing as a fraction bar, and you're probably more used to seeing it like this. And remember, this is just quotient rule, which says if you have the same base, like y and y are the bases here, and looks like a y, it's supposed to be a 4. If you have the same base, y here, quotient rule says you keep the same base if there's division in between, and you subtract the exponents. So 3 minus 4 gives us -1. But remember, it said we can only have an answer with positive exponents, and now that's where the negative exponent rule comes in. Negative exponent rule says that this is the same thing as 1 over all of this to the positive version of that exponent. And then we know we don't write like 1 as an exponent in like math. We don't like writing that as a coefficient or an exponent. So this is just 1 over y. So now let's go to this system of equations problem. So it says determine the point of intersection for these. So point of intersection is just another way of saying find the solution, because if the point that they intersect at is the point that works for both of them, so it's a solution for the system of equations. So what we're going to do here is I'm going to just use substitution since y is already isolated right here. So y is the same thing as this, 2x minus 1, so I can just plug that in for y in this equation and do substitution. So I'm going to do x plus, and then instead of y, I'm going to write 2x minus 1, and then I just copy down the rest of the problem, equals 7. The reason I'm doing this is because now I only have one unknown variable, x. So now I can solve for x. Before, I had x and y. I can't solve when I have two unknowns like that. So now I'm going to combine like terms on each side. So x plus 2x is going to be 3x, and then I have the minus 1 equals 7. Now I'm going to add 1 to each side, because I'm trying to solve for x, so I'm trying to move things away from x. So that's going to give me 3x is equal to 8. Then I'm going to divide by 3, and that's going to give me that x is equal to 8/3. Now remember, a point is always an x comma y, so I have x, but I need to find y now. So the way I'm going to do that is I'm going to just plug in what I found for x into this equation and solve for y. So y is equal to 2 times 8/3 for x minus 1. So y is equal to 2 times 8/3 is the same thing as 2 over 1 times 8/3. So when you're multiplying with fractions, you just multiply the top. So 2 times 8 is 16, and then multiply the bottom. 1 times 3 is 3. And then minus 1. So when we're adding or subtracting with fractions, we always have to make sure we have a common denominator. 1 is the same thing as 1 over 1, but that doesn't have a common denominator. This is a denominator of 3, this is a denominator of 1. We need them to be the same. One way that you can always easily do that is by just multiplying each fraction by the opposite denominator. So like 16 over 3, multiply the top and bottom by 1, which just keeps it as 16 over 3. And then for this one, multiply by the opposite denominator, 3 on top and bottom. 1 times 3 is 3. And 1 times 3 is 3. Now you have a like denominator, so we can subtract these and keep the like denominator of 3, and then subtract the numerators to get 13 over 3 for y. So that's what y equals, 13 over 3. So you might see this also as like mixed numbers, and like if we wanted to turn this into a mixed number, like 8 over 3 is just 8 divided by 3. So 3 goes into 8 2 times 3 is 6, minus we get 2. The remainder becomes your numerator in the mixed number, and the outside number is your denominator. So this would be 2 2/3 for x. And then for y, you would do the same exact thing. So you would just do, I'm going to do it down here, 13 divided by 3. So 3 goes into 13. That's going to be 4 times. 4 times 3 is 12. Subtract, you get 1. That's the remainder, which becomes the numerator in your mixed number. Outside number is the denominator. So this would be 4 1/3. Okay, so now let's go to the next problem. A ladder leans against a wall reaching 15 feet high. The base of the ladder is 9 feet from the wall. How long is the ladder? So we want to know how long is the ladder, and make sure your answer is fully simplified. Okay, so let's draw this out. We have a ladder. This is going to be our ladder. And then we have our wall right here. And then we have the ground down here. Now the ground and the wall make a perfect corner, a perfect right angle. So that's why I'm putting that little box there to show that this is a right triangle that's been formed. So we want to solve for x, how long the ladder is. We know that the wall is 15 feet high. And it says the base of the ladder, which is right here, is going to be 9 feet from the wall. So this is going to be 9 feet from there to there. So we basically know two sides of a right triangle, and we're trying to find the third. Whenever that happens, you use Pythagorean theorem, which is the thing that says a squared plus b squared equals c squared, where c is always your hypotenuse, the one that's like diagonal or across from the right angle. You could also think about it as it's like the longest side, but you don't know that from like x. So I think it's easier for students to just think it's the one directly across diagonal from the right angle. So I'm going to now plug in all the numbers. So a and b, it doesn't matter if you put 15 for a or if you put 9 for a, like a and b just have to be like the two sides that touch the perfect corner, that touch the right angle. So I'm going to just say that 15 is a, so 15 squared plus 9 squared is going to be equaling x squared. So that's going to be 15 squared is 225, 9 squared is 81, and that equals x squared. So then I have to add these up. So that would be 306 is equal to x squared. And remember, I'm solving for x, not x squared. So I have to get x by itself by doing the opposite, by moving the little 2, which I move it by doing the opposite operation, which is square rooting each side. So I have to square root each side, and that's going to give me that x is equal to the square root of 306, but then remember it said to fully simplify. So I have to ask myself, okay, well, what numbers multiply to give me 306? Because then I can take out any perfect squares. So hold on, let me think. Does 9 go into, yeah, 9 goes into that. So 9 times, that would be, wait, 34. Yeah, 9 times 34 gives us 306. So 34 times 9. So then I know 9 is a perfect square, so I can take that out. So the square root of 9 is 3, and then I have to leave the 34 inside the square root. And 34 does break up into like other factors, like for instance, like 2 times 17 would be 34, but neither of those are perfect squares like how 9 is to take out, and we can't break these up any further to get perfect squares. So we're at the end of our rope for this problem. Like we can't go any further to simplify it. So this is the final answer. And obviously in like feet. So then let's go to this problem right here. Whoopsies. So it says, find the volume of a cylinder with a radius of 3 centimeters and a height of 10 centimeters. Round your answer to the nearest hundredth. So volume of a cylinder, the formula is going to be pi r squared times h. So we know what r is. R is 3. So we're going to plug that in there. And we know what the height is. It's 10. So let's plug in all of our values. So r is 3, so 3 squared times the height, which is 10. So then you would just plug this into your calculator, and when you do, you get like 282.76, yada, yada, yada. And when you round it to the nearest hundredth, that would be like hundredth is 2 spaces after the decimal. So, or like 2 digits after the decimal. So like 1, 2. This would be where it has to stop if you're rounding to the nearest hundredth. And it would be 282.74. And then volume is always in cubic like whatever the unit is. In this case, it's centimeters. Okay, so then let's go to the next one. We're going to find the mean of this data set. So mean is always equal to the sum of the data divided by the number of items in the data set, like the number of like data points, basically. So if I want to find mean, I have to add all these up. So I have to do 4 plus 7 plus 3 plus 8. And then I have to divide by how many numbers are in my list of data, which is 1, 2, 3, 4 numbers. So that's all I have to do. So 7 plus 3 is 10, and then 4 plus 8 is 12. So 10 plus 12 is going to be 22, so 22 over 4. And then I'm just going to divide this. So 22, because remember, a fraction bar is the same thing as division. So 22 divided by 4. 4 goes into 25 times. 5 times 4 is 20. Subtract, we get 2. And so you could turn this into like a mixed number and say it's 2 over 4, but then you have to simplify that. Like 2 goes into 2 and 2 also goes into 4, so you divide by 2 on top and bottom. And that would be 5.5, or you could say that's 5.5, like either way works. Oops, I forgot to like show it. There we go. So you just have to make sure that you simplify right there, but it could be 5.5 or 5.5, doesn't matter. So then let's go to this next one right here. So this is one of the scale drawing problems. So with scale drawings, it's like basically like with maps and stuff, you can't draw like a whole building on a map like the same at the same scale. Like you have to size down. So like when you have, it says in this problem, we have a scale drawing of a building using a scale of 1 inch is equal to 10 feet, because like you can't just draw like a bazillion feet on a piece of paper. So they're saying like 1 inch is equivalent to 10 feet on like whatever the drawing is that you're doing. And if the building is 150 feet tall, how tall is it in the drawing? So we want to know how tall it is in the drawing when the building is 150 feet tall. So this, for scale drawings, you want to do the same thing that we were doing before with like direct proportions. So you have like a relationship on one side, a relationship on the other, and make sure the units match on top and bottom. So like the first relationship says that 1 inch is related to 10 feet. So 1 inch is equal to related to 10 feet. So that means that we have to maintain that inches are on the top and feet are on the bottom for the next relationship. The next relationship says if the building is 150 feet tall, so 150 feet, then we're basically finding how tall it is in inches, so X inches. So then we have to now cross multiply. 1 times 150 is 150. 10 times X is just 10X. And then I have to get X by itself, so I divide by 10 on each side. And that would give me that X is equal to 15 inches. So that would be the answer there. And that is it for the live today. If anybody has any questions, just put them in the comments and I'll answer them before I head out for the night. And if we don't get any questions in like the next minute or so, then I'll head out. No problem, guys. It looks like we're not getting any questions, so I'm gonna head out for the night. Remember, I do lives every Monday and Friday at 6 p.m. Eastern time. Bye, guys.